You are having a completely normal morning. You wake up, grab your phone, make some coffee, and go about your routine without giving any of it a second thought. And then the ground moves. Not an earthquake, not a tremor, something different, something deeper. And then, the sky to the northwest goes dark. In a way that has nothing to do with clouds. What you are watching is the Yellowstone supervolcano erupting. And in the next few minutes, hours, and days, everything you think you know about how the world works is going to stop being true. Let's start with the first 60 seconds. Yellowstone sits on top of a magma chamber so large that geologists measure it in cubic miles. The last time it erupted at full scale 640,000 years ago, it expelled approximately 240 cubic miles of material. To give you a reference point, the 1980 eruption of Mount St. Helens, which killed 57 people, flattened 230 square miles of forest, and was visible from 3 states, expelled less than 1/4 of 1 cubic mile. Yellowstone at full eruption is not Mount St. Helens scaled up. It is a completely different category of event. In the first 60 seconds, a column of ash, gas, and superheated rock fragments shoots into the atmosphere at supersonic speed, reaching an altitude of 30 miles or higher. For context, commercial aircraft cruise at 6 miles. The eruption column would be 5 times higher than the highest point any passenger jet has ever flown. The energy released in those first 60 seconds would exceed every nuclear weapon ever detonated in human history combined. Within the first few minutes, pyroclastic flows walls of superheated gas and rock moving at up to 450 miles per hour, and reaching temperatures of 1,000 degrees Celsius would begin racing outward from the caldera in every direction. Nothing in their path survives. Not buildings, not vehicles, not people. The pyroclastic flows would cover an area of roughly 100 miles in every direction from Yellowstone within hours. If you are in Wyoming, Montana, Idaho, or parts of Utah and Colorado when this happens, you need to understand something clearly. There is no evacuation. There is no outrunning a pyroclastic flow. The survival rate within the immediate zone approaches 0. Now let's talk about what happens to the rest of the United States. Within the first 24 hours, ash begins falling across the country, not the light dusting that people in distant cities sometimes get after smaller volcanic events. Thick, heavy, concrete-like ash that accumulates at rates of inches per hour in the states nearest the eruption. Kansas, Nebraska, South Dakota, North Dakota, states that have nothing to do with Yellowstone would receive ash accumulations of several feet within the first day. This matters more than most people realize. Volcanic ash is not like snow. It does not melt. It does not blow away in the wind the same way. It is dense, abrasive, and electrically conductive. A few inches of wet volcanic ash on a roof collapses that roof. A few inches on a road makes it impassable. A small amount inhaled causes serious lung damage. And it gets into everything: engines, water supplies, electrical equipment, food supplies. Within 24 to 48 hours, the U.S. road network across the Great Plains would be functionally unusable. The railway system, which carries most of the country's food supply, would grind to a halt across thousands of miles. Airports across the central and eastern United States would close indefinitely. And the electrical grid, which is far more vulnerable to ash contamination than most people know, would begin failing and cascading outages across multiple states simultaneously. Here is where it gets global. Within 72 hours, the ash cloud from a Yellowstone supereruption would begin spreading into the upper atmosphere worldwide. Not ash you can see falling from the sky in Tokyo or London, but sulfur dioxide particles that would begin doing something far more dangerous than falling ash. They would start blocking sunlight. The injection of sulfur dioxide into the stratosphere from a supereruption of this scale would begin measurably reducing global temperatures within weeks. Climate models suggest a Yellowstone supereruption could drop average global temperatures by 5 to 10 degrees Celsius within the first year. To give you a reference point, the difference between the current global average temperature and the last ice age was approximately 6 degrees Celsius. This is the phenomenon known as a volcanic winter, and it is where the story stops being about one country and starts being about the survival of human civilization. At a 5-degree global temperature drop, growing seasons shorten dramatically across every major agricultural region on Earth. Crops that depend on predictable frost-free windows, corn, wheat, soybeans, rice begin failing not in one country, but simultaneously worldwide. Fertilizer production, which depends on natural gas supplies that are now disrupted, cannot compensate. Within 1 to 2 years of a Yellowstone supereruption, global food production would drop by an estimated 50 to 80%. The current human population is 8 billion people. The current global food system, even in a normal year, operates with extremely thin margins. Most countries maintain food reserves of weeks to a few months, not years. A 50 to 80% drop in global food production sustained over multiple years would produce a famine of a scale that has no historical comparison. Researchers who model these scenarios use careful language. They talk about civilizational stress, systemic collapse, cascading failure across interconnected systems. What they are describing, without using the word directly, is a scenario where a significant fraction of human civilization does not survive. Now, here is something important. The probability that Yellowstone erupts tomorrow, or this year, or this century at full supereruption scale is extremely low. The USGS, the United States Geological Survey, monitors Yellowstone continuously with hundreds of sensors and publishes regular updates. Scientists who study Yellowstone emphasize consistently that there are no signs of an impending supereruption, and that the system shows no unusual activity beyond what is normal for an active volcanic system. The last 3 supereruptions at Yellowstone occurred approximately 2.1 million years ago, 1.3 million years ago, and 640,000 years ago. The intervals between them were roughly 700,000 and 660,000 years. It has been 640,000 years since the last one. We are, statistically speaking, not overdue. The pattern is irregular and does not operate on a fixed schedule. But here is why scientists still study this scenario seriously. Because Yellowstone is real. Because the magma chamber is real. Because the geological record of what happened the last 3 times is real. And because understanding what a supereruption would do to modern civilization is not about predicting an imminent disaster. It is about understanding how genuinely fragile the systems that keep 8 billion people alive actually are. The electrical grid that powers every hospital. The road network that delivers every food shipment. The agricultural system that feeds every person on Earth. The global supply chains that move every medicine, every fuel, every piece of equipment that modern civilization depends on. All of it was built in a period of unusual geological calm. None of it was designed with a supervolcano in mind. A Yellowstone supereruption would not end human civilization. The species would survive. People have survived volcanic winters before the Toba supervolcano eruption, approximately 74,000 years ago, may have reduced the entire human population to as few as 10,000 individuals, and we recovered. But the civilization we have built, the specific arrangements of technology, infrastructure, supply chains, and population that define life in the 21st century, would not survive intact. What came out the other side would be different in ways that are genuinely difficult to predict and genuinely difficult to comprehend. And that is the thing about Yellowstone that researchers keep coming back to. Not that it will definitely erupt, not that an eruption is imminent, but that sitting beneath one of the most beautiful national parks in the United States, visited by millions of tourists every year who walk across geysers and hot springs, and the thin crust above one of the most powerful geological systems on the planet, is a reminder. The stability we live in is real, but it is not permanent, and it is not guaranteed.